everybody, this is a lesson on the cosine ratio. The cosine is one of our trigonometric ratios. We've got sine, cosine, and tangent. We're going to be talking about cosine, and it's one of the useful tools that you'll be using for finding missing sides and angles in your right triangles. So we'll get started. You need to know that the cosine ratio is a relationship between two sides in these right triangles, and it is the adjacent side over the hypotenuse. When you have a right triangle, you're always going to have an adjacent, an opposite, and a hypotenuse. You will always know which side is the hypotenuse because it will be the longest of your sides. It will also be across from the 90-degree angle symbol in your triangle. The adjacent will be attached to whatever angle you're referring to. So that's very important that you remember cosine is going to be found based on what angle we are looking at. It's going to depend on where our adjacent and our opposite sides are. So let me show you here. Cosine of C, that is this angle right here. It needs to be the adjacent over the hypotenuse. So we're going to be looking at the adjacent side to C, the one that's sort of attached to C, not the one across, okay, over hypotenuse, which we mentioned was the longest side. Alright, so let's practice. Let's find the cosine of angle A. So first, you've always got to look and see where is angle A. Where's the angle that we need to be looking at? And that is here, because it's going to matter how we label the sides of our triangle. So cosine is going to be found by taking adjacent side over hypotenuse. So adjacent, the one attached to A, is here. That's 12. Hypotenuse, I don't have the right angle symbol labeled this time in my picture, but I can see that the longest side is 13, so I know that's the hypotenuse. So cosine of A is 12 over 13. Want to look at that fraction and make sure that it is in simplest form. It cannot be reduced, so we'll leave it at 12 over 13. Okay? One other cool thing you can do with this cosine ratio is you can actually find the angle of the triangle that you're looking for. By using the inverse cosine, we can find the measure of angle A. We can find the measure of any of these, but we're going to try for A. So here's our A. We want to identify where that's at. The cosine of A, remember, we said was 12 over 13, adjacent over hypotenuse. So remember, since cosine of A was 12 over 13, if we wanted to find just A, we would need to solve for that. Anytime you're solving an equation, you're trying to get that variable, what it is you're looking for, by itself, all alone. So I would need to get rid of this cosine. So the way to do that is inverse cosine. If I take the inverse cosine of both sides of this equation, so let me rewrite what we have. It would look like this. So I've got cosine inverse of cosine A equals cosine inverse of 12 over 13. I just attached a cosine inverse to both sides so that I could sort of undo that cosine operation, get rid of it, and leave A by itself. And I can see I need to type this in to my calculator on the other side. So I'm going to type in cosine inverse of 12 over 13 as a fraction. So on your calculator, if you look above the cosine button, COS, you should see the cosine inverse operation, and to access that you usually press the second key on your calculator, the one at the top. It will allow you to access those commands that are above the normal buttons. So check that out, find it, type in cosine inverse of 12 over 13, and I'm going to do that while you do yours. Cosine inverse, make sure you get that 12 over 13 as a fraction, just how it looks here. And I'm coming up with 22.62 roughly degrees. So we just found angle A. Now another neat thing that I want to tell you about involving cosine is that the cosine of an angle is equal to the sine of the complement of that angle. So cosine is adjacent over hypotenuse, we've talked about. Sine is opposite over hypotenuse. and the cosines and sines of complementary angles are equal. So I'm going to show you what that means here in this picture. Cosine of h, if we needed to find that, we would go over here, identify where h is at, find the adjacent over the hypotenuse. So we've got adjacent, hypotenuse, 3 over 5. Okay? The sine, which is another trig ratio you will learn about, is opposite over hypotenuse. The sine of j, which is the complementary angle to h, is opposite over hypotenuse. Opposites here from j. Hypotenuse is still the same as our 5. So you can see, again, it's 3 over 5. So the cosines and sines of complementary angles are the same. The reason why we know that j and h are complementary angles adding up to 90 degrees is because you'll usually see a right angle symbol in your right triangle, and that's a 90 degrees. And all of your angles have to add up to 180 every time in a triangle, so that forces the other two to add up to make up the other 90 degrees. So that's pretty neat. So 2 things to remember about our cosine ratio is that it is found by taking the adjacent over the hypotenuse sides of the triangle, and that the cosine of an angle is going to be equal to the sine of the complement of that angle. And this is going to conclude our lesson on the cosine ratio.